Okay, class, I want to finish setting up this tank draining example. We'd finished off on the last video getting to this point. We had the time rate of change, the height of the water in the tank was equal to a negative 2g to the 1/2 power, the square root of that, divided by rho A, the density of the liquid in the tank, times the tank's cross-sectional area, times z to the 1/2. And all I'm going to do is simplify this expression by grouping like terms. These terms on the right-hand side are a constant. So I've got the square root of 2g integrated from 0 to t. That's just going to be t as the integral answer. So the only trickier part is dz over z to the 1/2. And as a student, these always frustrated me, so I just learned to write them as z to the negative 1/2 dz. And this is going to go from an initial height of liquid in the tank of 12.5 meters down to an empty tank of 0 meters. So z to the negative 1/2, I add 1 to the exponent, which gives me 1/2, and then I divide by that exponent. So I get, as a solution to the integral, 2z to the 1/2, and this is integrated from 12.5 meters down to 0 meters. And I've got this equal to a negative 2g, so that's 2 times 9.81. And again, I take the square root of that, and that's divided by rho A. Rho was 10 kilograms per cubic meter. A was 20 square meters. And we saw in the last one, this would give us meters per minute as units. So let's go ahead and this is multiplied by t because that's the integral right here on the right hand side. So let's go ahead and evaluate these constants. The square root of 2 times g I get to be 4.429. And in the denominator here, I get a value of 200 as rho times A. That gives me a constant of 0.02215 times T. So I've got on the left side 2 times the square root of Z is equal to 0.02215 times the time elapsed T. So this is my equation for Z as a function of T. Now all you have to do, guys, is go ahead and plot this from 12.5 meters down to the value of 0 where the tank is emptied. So immediately you can plug in 12.5 meters here and find out the time it's going to take to drain the tank, and then it's your job to figure out the best way to plot Z as a function of T in your Excel chart. You just use the methods we shown in the first assignment to do that. Thank you.